Meet Brian White, a young lieutenant fresh out of the academy, ready for his first assignment on the police force. His first assignment is to infiltrate a car racing ring which has been terrorizing the town. To do this, he must first learn physics, for some reason, in order to build a fast car so that he can win and earn the other racers' respect. The problem is, Brian White took a double lunch during high school, and he doesn't know any physics. So first, he has to learn Newton's laws. Today we will be discussing forces. Force is defined as a push or a pull which acts between two objects. This could be a rocket engine pushing a rocket upward, the engine of a car pushing it forward, a rope pulling a bucket of water out of a well, or gravity pulling downward on a plain old box full of cats. There's nothing strange about that. One important thing to note about forces is that all forces are vectors, meaning they have both magnitude and direction. So to better understand forces, we need to talk about some of the types of forces we commonly encounter. The first force we need to discuss is gravity. To understand gravity, we need to back up to the year 1666, when a young Isaac Newton was at home sitting under an apple tree. The story goes that an apple fell from the tree and hit Newton on the head. The falling apple got Newton thinking about what keeps the moon in orbit around the Earth. The answer Newton came up with was gravity. For now, let's just worry about the apple though. We'll worry about orbits and the moon much later. Gravity is defined as the attractive force between two objects which exists due to their mass. Now, all objects have mass and therefore are attracted to all other masses due to the force of gravity. The more massive an object is, the greater the force of attraction it's going to have on its surrounding objects. Now, even though there's a gravitational force of attraction between you and a person you walk past on the road, you don't feel it. Neither of you really has all that much mass, so the force of attraction between you is going to be very weak. Earth, however, is very massive. Because it has so much mass, you and anything else near the surface of the Earth are rather strongly attracted to it through the force of gravity. The force of gravity is more commonly referred to as weight. The weight of an object is given by the equation force due to gravity equals mg, where m is the mass of an object, and g is the acceleration due to gravity, which on the surface of the Earth is 9.81 meters per second squared. Next, we have the normal force. The normal force is a contact force that exists between two objects because two objects can't occupy the same space. More simply put, the normal force is the reason objects can't pass through each other like ghosts. The normal force between you and the ground keeps you from sinking into the ground like it's made of quicksand. And the normal force is why you can't walk through walls. Most importantly, it's why cats stay trapped in a box until you take the lid off. When we say the normal force is a contact force, that means unlike gravity, which can act over a long distance, it only acts when two objects are actually touching each other. So like a person trying to walk down the road texting on their phone, they don't feel the lamp until they run directly into it. Next is friction. Friction is a contact force that resists the relative motion between two objects. Really, friction just tries to keep two objects from sliding against each other. Take, for example, the tires of a car. The friction between tires and the ground is really just what we call traction. That traction is needed when you press the brakes to slow the car down, and when you press the accelerator to, accelerate the car forward. It's also needed when you want to drive the car around a corner. All that traction is really just the result of friction between the tires and the road. Now there's lots of other forces too, but we'll get to those later. In 1666, Isaac Newton sat down and penned 3 laws that would eventually come to be called, you guessed it, Newton's laws. Newton's first law is broken up into 2 parts. The first part says, an object at rest will remain at rest unless acted on by an unbalanced force. Now it's important to understand that just because an object is stationary does not mean there are no forces acting on it. Imagine 2 people pulling a block in opposite directions. The block does not move, but there are still forces acting on the block. The forces just cancel each other out. When all of the forces acting on an object cancel each other out, we say the forces are balanced, or we say the object is in equilibrium. The same goes for a block sitting on the ground. Gravity pulls down on the block, and the force from the ground pushes up equally. So the 2 forces cancel each other out, or they're balanced. The second part of the first law says, an object in motion will remain in motion unless acted on by an unbalanced force. Really, all this means is that a moving object is going to keep moving until something stops it. Objects don't just magically stop. So what happens to an object when the forces on it are unbalanced? Newton's second law says, the net external force acting on an object is the product of its mass and acceleration. Or in a simpler way, net force equals mass times acceleration. By using the second law, we can see that force has units of kilograms times meters per second squared. But that's a mouthful, so we can just call them newtons, because of, Newton. Now what the second law means is that for a given mass, the greater the net force acting on an object, the greater its acceleration will be. Conversely, this means that for a given force, the larger the mass it acts on, the less acceleration it will produce. Finally, there's Newton's third law. Newton's third law states that for every action, there's an equal and opposite reaction. Now realize, while this law is often applied to many things outside of physics, this law only applies to action and reaction forces. This does not apply to human behavior. If it did, my 3-year-old would not lie down sobbing on the floor because a squirrel is playing in the backyard. But believe me, she does. According to the third law, if a person pushes on a block horizontally, then the block must push back on the person in the opposite direction. The strange part of Newton's third law is that unlike the first and second laws, where we're only concerned with the forces acting on an object, the third law looks at both the forces on an object as well as by an object. So what do we do with Newton's laws, and how do we apply them? Well, we're going to save that for another day. Having learned everything he needed to about physics, Lieutenant White suited up and set off in his shiny new car to infiltrate the car racing ring.